What's up everyone, Lakonde Mwila here, back with another video, and we're talking K8s. If you've got your ear to the ground in the cloud native space, then you probably know that security around containers and Kubernetes is a very hot topic right now, perhaps for obvious reasons. In fact, I was at AWS Reinforce last month and it was amazing to see the number of companies producing cloud monitoring solutions and are investing heavily in features focused on securing your container and K8s workloads. Now, as much as I'm an advocate for containers and Kubernetes, I do try to give a balanced perspective on the pros and cons of using them, and one of the cons is that they're insecure by default, and that's a glaring feature. I had the chance to present to some people recently, and someone in the room asked, how will containers and Kubernetes improve my security posture? That's a great question. So I told them straight, it won't. You should have seen the room. Anyway, I did go on to share that it's not really what they're made for. It's kind of the same as asking, will Cristiano Ronaldo improve the number of clean sheets that we get as a team? Or will Steph Curry help me get more blocks? It's not really their job, but they're great at other things. So we just complement their strengths with good defensive pieces. And we don't want to throw the baby out with the bathwater. In the right context, containers are great for workload portability and achieving consistency for your applications across different environments. And similarly, Kubernetes is great for orchestration of large container workloads and managing their underlying infrastructure with self-healing capabilities. But we need to do something about the security vulnerabilities, and that's a huge topic. But I'm going to cover some of it in this video, specifically how you can address some of the vulnerabilities in the supply chain. The tools in this video may have caught your attention, and if they did, I'm glad. In reality, when it comes to improving your container and Kubernetes security posture, you want to start by identifying the vulnerabilities and then pick a tool or tools that will help you address the relevant risks. Another reason I picked a number of tools is that I'm trying to add as many layers of defense as possible to mitigate the chances of a breach or reduce the chances of potential attacks. And that's essentially what defense in depth is. If you can find a tool that takes care of a number of issues, then by all means go for it. Firstly, let's talk about the software supply chain. This refers to the various activities involved in the software development lifecycle, from initial development to a destination runtime environment and ongoing maintenance and management. Securing the software supply chain entails securing the different components in this process, from developer practices to dependency libraries, infrastructure components, network protocols, external integrations, and deployment methods. And there are different measures that you can take. In this video, I want to demonstrate two approaches, namely image and repository scanning and admission control policies. So let's take a look at that. One of the biggest attack vectors stems from the dependencies and libraries that you import into your application. And these are open source projects that have their own vulnerabilities. And the more of them that you have, well, the larger your attack surface area will be. So ideally, you want to keep things thin and light. One of the ways that these vulnerabilities creep in is through your container's base image. After building my container images locally, I like to scan them to see what vulnerabilities actually exist, along with their level of severity, because you need to budget for certain levels of risk in different cases. And I'm going to use Snyk for that because it will also give me some suggestions around more secure base images that I can use, if any exist. So, bear in mind, this is the simple command to run a test against this particular container image, and that is for this application over here. And the actual version number, let me just open the package.json file, is 0.2.5, which you will see in the production pipeline. I will call it that, the actual pipeline that I've provisioned in AWS code build. But to test it locally, I've just tagged it differently, orders test 0.1.0, just for clarity in case you get confused, because I will refer to the other one in AWS code build shortly. And I'm going to run this test. All right, so I'm just going to scroll up so you can see all the results over here. We've got two that are of high severity, and we've got one that is critical. But take a look at this over here. According to our scan, you are currently using the most secure version of the selected base image. So despite the detection of the critical finding and two other high issues, I'm using the most secure base image. Now, depending on your appetite and budget for risk, you can either proceed with this same base image, or you can build your own. Now, it's important to understand that the CVE database records for these vulnerabilities are continuously being updated. So a month ago, this base image would actually have been considered pretty secure. And let me show you a pipeline for this same image in AWS code build. I was referring to this earlier. So you'll see over here, orders backend dev. So this is referring to this is the pipeline for this exact same application that I just showed you. And this was run in July, as you can see over here. And I'm going to scroll down specifically to the section where I was running a Snyk test in the CI stage. There we go. So you can see the same command over here, Snyk test with Docker severity threshold was set to critical. And this is the specific image repository and the tag for it, 0.2.5, as you can see over there. And it was tested and there were no issues that were found. And you can see over there, get the same message. You're currently using the most secure version of the selected base image. And so there were no critical issues that were found. If there were any at that point in time, then the build would have actually failed. So what does this tell us? A couple of things. Firstly, as you've seen, this build run July 16th. And there were no issues, no critical issues that were detected. That's why the pipeline passed and the image was pushed to my ECR repository. However, let's take a look at this critical finding. You can see over there, 9.8 score. That's pretty high. Now, look over here, you'll see introduced 5th of August. All right, so this was only published about, several weeks after that particular pipeline run. And so at that point in time in July, it was considered relatively secure, but now new issues have been found in that base image. So as you can see, simply running local scans or in the pipeline, as I did, is insufficient because it's based on data that has been added to the CVE databases, which presents a challenge for new vulnerabilities that haven't been added yet. Now, look, we want to continue with these activities because they're still helpful, but how do we protect ourselves from situations like this when vulnerabilities come up later in the future and we already have a container running with an image that was once considered secure? And there are different approaches, and one of them is to continue running scans on your container image repos. So as opposed to just relying on a once-off event in the pipeline, you can continue vetting your image according to any new CVE updates that come up. And for that, I'm using Amazon Inspector. And so this is going to enable me to scan my repositories and images on an ongoing basis. And so you'll see over here, I'm in Inspector and I've specifically gone to the findings and by repository. And this is the same repository, Lukonde Mwila e-commerce orders for that application. Just so you can see over here, this was the particular image that was pushed through to my ECR repository, and this is what I'm scanning for. So you'll see there a couple of versions here, 0.2.3, 0.2.4. 0.2.5 is the latest one. That's the one that actually passed in this pipeline and ended up here. So that's the one that I'm specifically referring to. You'll see each of them has a status of scanning because they're continuously being scanned. You'll notice over here under the different levels of severity, we've got critical, we've got high, and you can see the things that have been detected. So 0.2.5 would still be considered relatively secure compared to the previous versions, which is a good thing. And I'm going to open up another tab over here. And this is the findings for the particular image. So I've just zoned in on 0.2.5. And you'll see over here, we've got this one with a high level of severity. And we've seen it. This was only detected 9 days ago. So this way, even if the last pipeline execution from a month ago had a scan that gave the green light on the image, Inspector's continuous monitoring will flag any new issues. And you'll see here that I have this vulnerability that was detected 9 days ago. And from there, you can make a decision to patch and secure your image in light of the new findings. So you're not in the dark about new findings and risks for existing workloads. And of course, for those of you that are interested, and I think this is also very important, be sure to actually check out the details of this particular vulnerability that has been detected and is in the CVE database. And you can see the level of severity, of course, that's also highlighted over here. But in addition, you can read more about how this can actually be used by potential attackers or hackers and the implications on your application with a lot more details about it. So that's a huge help as well. All right, so scanning is just one way of dealing with the different attack vectors. Another important approach you can use in securing your Kubernetes software supply chain is that of policies to control what ends up in your cluster. If you watched some of my previous videos, you've probably seen me demonstrate Datree a lot. And in this video, I'm going to couple it with NeuVector. But let's start with Datree. So similar to Snyk, I like to use Datree locally and in the pipeline. And Datree allows you to create policies, as you can see over here on the left-hand side. And you would simply create one by clicking on the create policy. And these policies allow you to essentially toggle and enable or disable features, as you can see over here. And these features are based on best practices and security features for your container workloads that will run in Kubernetes. So it's a great protective measure to prevent deploying workloads that don't meet certain criteria. So let's take a look at a deployment manifest file where I'm committing a couple of fouls, and you'll see that over here. You'll notice that I have host network, host PID, and host IPC all set to true. Now, each of these is bad for reasons which I explain in another video of mine on container best practices with Datree, and you can find the link to that in the description below. But let me go ahead and run a Datree test referring to my default policy. So this is my default policy over here. So a couple of rules are already come preset for you, but I have added some. So this, you won't start off with 34 out of 60 as mine are. And you'll see the ones highlighted right at the top are the container specific rules. But I'm going to head over to the terminal, and I am inside a directory called K8's manifests. And this is the same directory where my deployment file lives. So if I just run that, you'll see that it's the exact same one. Just clear that. I'm going to run Datree test against that. Great. So you can see we've got a failure for each one of these that I mentioned and set to true. So these failures are based on the settings of my default policy. And as I mentioned, I've modified my default policy to include additional rules. And also, I run these checks in the pipeline as well, not just locally. So if I head to a previous build, this is the same one that I referred to earlier. So this is for the orders microservice. I'm just going to scroll down to the section where I was running a test with Datree. Let me keep scrolling. There we go. So you'll see over here running command helm Datree test. So I was testing the Helm charts for the orders microservice. And at this particular, for this particular build, my workload met all the right criteria and hence it passed. You'll see that there were no failures at all, 35 out of 35. Okay, so when I run it against the Helm chart configurations, it passed as I mentioned. So running tests with Datree locally and in the pipeline is great. But what happens when you have some developers or operators that want to circumvent the system and deploy directly to the cluster? How do you add another defensive layer or security gate that will basically be like Gandalf and say, you shall not pass? For that, I'm going to use NeuVector. All right, and so NeuVector is a very comprehensive cloud native security tool, but I specifically want to highlight its admission control policy feature. And admission control policies essentially allow you to create rules, either allow rules or deny rules for your workloads. So somewhat similar to Datree as well. And I'm going to click on the specific one that I just created. So this is the edit view. I've already created it. And so what I'm going to do over here is I just want you to see that it's a deny rule, as you can see over there. That's the type. And it is meant to deny any deployment resource that has host network, host PID, and host IPC set to true, as you can see over here. Now, something else that's important to note about admission control policies is that you can either set them to monitoring mode. You can see just you simply toggle between the two over there, or protect mode. I'm going to leave it in protect mode, which is what it was before. And the monitoring mode would simply produce a warning. Protect mode is like a strict mode and essentially rejects the resource that doesn't meet the criteria altogether. So if your team has people that are notorious for ad hoc kubectl commands and circumventing deployment streams that you have in place, this is a good way to prevent them from deploying insecure workloads. But not only individuals that might want to run ad hoc commands, of course, it's just another way of protecting your cluster as a whole to ensure that it rejects any insecure workloads, even if they are coming through the pipeline. So I'm going to come to the terminal, and what I'm going to do now, I'm just going to clear the screen, and I'm going to attempt to create this deployment manifest file. I'm already connected to that cluster where NeuVector is running. And there you go. As you can see, error from server, error when creating this particular deployment manifest file. And we can see the admission webhook over there. It failed. And so creation of Kubernetes deployment is denied because of those same rules I've put in place. And so this is a great protective feature. So you can couple the power of Datree and NeuVector, not only for protection locally and in the pipeline, but also creating another security gate for your cluster to ensure that you never have insecure workloads like this deployment manifest that I just demonstrated from ever ending up inside of your runtime environments.